So the Laplace transforms have linear properties. So if alpha and beta are constants, then the Laplace transform of alpha f of t plus beta g of t is the same as saying it's alpha times the Laplace transform of f of t plus beta times the Laplace transform of g of t. So this is the same as when we did derivatives and limits and integrals. If we have separate terms, we look at them each separately. We don't have to try and put it all together into one term. So for example, if I have the Laplace transform of 3t plus 5, I'm really just looking at 3 times the Laplace transform of t plus 5 times the Laplace transform of 1. So that gives me 3 times 1 over s squared plus 5 times 1 over s. So 3 over s squared plus 5 over s. And if we wanted to put it together into one, which they do a lot for this unless they get really complex, I would just need to multiply the second one by s over s. And that would give me 3 plus 5s all over s squared. Or if I have t squared minus 2t plus 3, again, I'm looking at the Laplace transforms of each one separately. So Laplace of t squared minus 2 times the Laplace of t plus 3 times the Laplace of 1. So this t squared is 2 factorial over s to the n plus 1, so s cubed, minus 2 over s squared plus 3 over s. So again, I can get a common denominator and pull them all together. So s cubed is the common denominator. So I get 2 minus 2 times s plus 3 times s squared all over s cubed. Alright, so those are the linear factors. So let's find another Laplace. I want to find the Laplace transform of e to the 4t. So 0 to infinity, e to the negative st times e to the 4t. So I can put those together because they have the same base. So I get e to the negative s plus 4 times t. Did I mess up my sign? I factored out a negative. Yes, I did. This should be a negative. E to the negative s minus 4 times t dt. So limit as b goes to infinity, 0 to b, e to the negative s minus 4 t dt. And this is just a constant. So when I integrate that, I get negative 1 over s minus 4 times 1 over e to the s minus 4 dt if I get rid of that negative exponent from 0 to b. So that negative 1 times s minus 4, I'm just going to factor it out for now, and then we can multiply it back through. So when I plug in b, I get 1 over e to the s minus 4 times b minus 1 over e to the 0. So when I take that limit as b goes to infinity, this term goes to 0, and this term goes to 1. So it just equals negative 1 over s minus 4 times negative 1. We just get 1 over s minus 4. So here's our next Laplace transform. So in general, the Laplace transform of e to the at equals 1 over s minus a. So I'm going to write out 7 Laplace transforms. We've proven a couple, and then some of the trig ones that I'm not proving out for you. So the Laplace transform of 1 was 1 over s. The Laplace transform of t to the n, so it could be just t to the 1. But t to the n in general is n factorial over s to the n plus 1. The Laplace transform of e to the at is 1 over s minus a. And then these we haven't proven out, but the Laplace transform of cosine of kt is equal to s over s squared plus k squared. The Laplace transform of sine of kt is equal to k over s squared plus k squared. So the cosine has a s in the numerator and the sine has a k in the numerator. The denominators are the same. The Laplace transform of cosh, kt, hyperbolic cosine, is s over s squared minus k squared. So you see the difference between cosine and cosh is on the bottom, instead of a plus, it's now a minus. Oops. And the Laplace transform of sinh, kt, is equal to k over s squared minus k squared. So if I have the Laplace transform of t cubed plus e to the 2t, the t cubed is going to be 3 factorial over s to the n plus 1, so s to the 4th. And then e to the 2t is 1 over s minus 2. So we get 6 there. And again, if I want to put it together, I need to multiply this fraction by s minus 2 over s minus 2. So I get 6 times s minus 2. And then this one I have to multiply it by s to the 4th. So 1 times s to the 4th over s to the 4th times s minus 2. So that would give me s to the 4th plus 6s, s, not x, minus 12 over s to the 4th times s minus 2. And a Laplace of 3 times the sine of 5t. I'm going to get, that 3 is just multiplied out, so I get 3 times 5 s squared plus 5 squared, which would just give me 15 over s squared plus 25.